find out the marginal rate of technical substitution between labor and capital of a homogeneous Cobb-Douglas production function. The question is, we are being told to find out the MRTS of a homogeneous Cobb-Douglas production function. Options are being given. We need to find out the correct option. Okay, so we write our standard Cobb-Douglas production function in this form. That is, output is equal to A times L to the power alpha times K to the power beta. Okay, A denotes the total factor productivity, alpha denotes the output elasticity of how do I write it? Output elasticity of labor. Okay, so let's denote it by output. E denotes the elasticity. Let us, I am doing this symbolization, otherwise it is not given. Output elasticity of labor, and this denotes the output elasticity of capital. Okay, so this simply tells us, and this total factor productivity shows us the change in the output which is not being shown by the change in the labor or capital. Okay, that is explicitly the change in the output which is explicitly by the state of technology. Okay, that we call the total factor productivity. We also call it the solo residual. Now to find out the MRTS, that is marginal rate of technical substitution between labor and capital, it is simply equal to the ratio of the marginal product of labor and marginal product of capital. Okay, so MRTS between labor and capital is equal to marginal product of labor is simply the change in the output due to the change in the units of labor employed, which is the partial derivative of this production function with respect to L. Similarly, MRTS, rather the marginal product of capital, means the change in the output due to the change in the units of capital employed, which is the partial derivative of the production function with respect to K. Okay, so which will be equal to, so differentiating this with respect to L by power function rule, exponent of L becomes coefficient, so we get alpha A L raised power alpha minus 1, and exponent is subtracted by 1 by power function rule, K to the power beta. Similarly, dq upon dk means the partial derivative of this production function with respect to K. This time the exponent of K becomes coefficient, so we have beta, the exponent of K, A L to the power alpha remains same, and exponent of K is subtracted by 1, so we get alpha minus 1. So we get here A and A gets cancelled. Solving further, so we have alpha upon beta. Okay, here let's transpose this term to numerator. So in the numerator we have K to the power beta. Transposing this, the exponent sign changes, it gets multiplied with the term in the numerator, so we have K to the power minus alpha plus 1. Okay, when we transpose any term from denominator to numerator, it gets multiplied, but the exponent sign is changed. If it is plus alpha, it becomes minus alpha. If it is minus 1, it becomes plus 1. Similarly, when I transpose this term to denominator, it gets multiplied with this L to the power alpha, but the exponent will change. So we have alpha, it becomes minus alpha. Here we have minus 1, it becomes plus 1. Okay, so MRTS, if I write it here, marginal rate of technical substitution between labor and capital will be equal to alpha upon beta times, bases are same, we can add up the exponent, so we will get here. Okay, so let me see if I have done some okay, we have beta here. Okay, that's why I was getting confused. So here we have also beta. Okay, so bases are same, we can add up the exponent, so we get beta minus beta plus 1. And similarly here in the new denominator, again we have the same basis, we get alpha minus alpha plus 1, so we will get alpha upon beta. Beta minus beta is equal to 0, so we get 0 plus 1 is equal to 1, so we get K upon L. Okay, so this is our marginal rate of technical substitution between labor and capital of a homogeneous Cobb-Douglas production function. So the correct option should be B option.